All right, so 1.5, what we were talking about variables on both sides of the equation. Okay, variables on both sides. You've done this before, but this is probably the hardest thing that you did with equations last year, is my assumption. It's as far as you went with equations, and we're going to keep going further after this. So this should be a little bit of review, but let's see what we can do, okay? Because it's been a while for some of us. So the first one we're going to look at, we got 10 minus 4x is equal to negative 9x. We have variables on both sides. Our goal still is to figure out what x is equal to get the variable by itself. Okay, you cannot have two variables inside of an equation. We need to get those together. We need to combine them into one variable. Now, if the variables are on the same side of the equal sign, we saw that last week. Variables are on the same side, we combine like terms, right? Let's say it was 4x plus 3x equals 14, right? Same side of the equal sign, combine like terms, nice and easy, we can do it. Where they're on different sides of the equal sign, we cannot just add those together. Okay, we cannot simply combine those like terms. We have to move one of the variables to the other side to meet up with the other. Okay, so in this case, I'm going to say we gotta move the variable. Okay, we have to move the variable to the other side. Now, which of these variables do you think we should be moving? That negative 4x or that negative 9x? James? Why?
Well, because we could add negative 4x on each side. Maybe.
Okay, so I could do that, right? I could. I'm not going to add negative 4x. I'm just going to add 4x. So it's going to get me over here, and all my x's will be over here. I could add 9x and move it all over here. But what's happening on the right side? It's all gone, right? So if it's all gone, then I would have to put a 0 there, and I would still have to move the 10. So if there's one side that has just a variable, let's move all the variables to that side. Okay. Sometimes students get so focused on, I need to get the variables to the left side, or I need to get the variables to the right side. You need to be able to move those variables wherever it's most convenient. Okay? And in this case, it's going to be to move them over. So just like when we were getting rid of stuff last week, okay, we want to get rid of this negative 4x. We want to move it. So I've got negative 4x. We do the opposite of that. I'm going to add 4x to both sides. Right? Because really what I want to do is I want to get that variable gone from that left side. So those are going to cancel each other out, just like when I have subtraction. Right? So I'm going to add the 4x to both sides. Whatever's left over, I bring down. I've got a 10 there. And now on the right side, I've got negative 9x plus 4x. What is negative 9x plus 4x going to give us? Cody? Negative 5x. Okay. So I combine those. I asked that because some of us got that wrong on the quiz. Stuff like that, where we're adding positives and negatives together. Okay, got to be careful on that. So we got a negative 5x, and from there, right, we know what to do. And we got a negative 2. So really the only difference here is we're getting those variables together on the same side of the equal sign. We're moving variables over to the opposite side. And to do that, it's always going to be addition, subtraction. You're never going to multiply a variable or divide a variable. We're adding or subtracting that variable over to the other side, depending on what your sign is. Okay. All right, let's look at another one. Let's go 8 plus 2x is equal to 14 minus 4x. So I want you to get the variables together on one side first, then worry about the other numbers. Okay? Get the variables together on one side first, and then you can solve it. Okay, go ahead, let's see what you can do. Make sure we're showing work. Right? Always showing work, always writing it down. And as you're getting close to solving it, remember, if there's no decimal in the question, there's no decimal in the answer. Fraction. No, it's gonna work out. Oh, I just said. Okay, go ahead, talk to somebody about it. What'd you do? How'd you get there? What'd you get?
What you get? Same thing, so less hand motions and more.
All right, here we go. How many of you guys subtracted 2x right away? Okay, you can subtract 2x. How many people added 4x? Which do you think I would have done? And why? Me being the one that knows the most efficient way most of the time. Tyler, what do you think?
The 2x over to the negative 4x.
Okay, why do you think that?
Because then you can solve it that way.
Okay, I can solve it either way. Right? Drew, what do you think?
I just added 4x to each side.
Okay, why?
Because it's so easier than like dealing with the negative.
Exactly. I'm going to try to keep things positive as much as I can, right? So we don't have to worry about those negatives. So yeah, just like Drew said, I'm going to add that 4x over. Because adding that 4x over, now I have 8 plus 6x. I don't have to worry about a negative sign anymore. I got 8 plus 6x equals a positive 14. I got no negatives left in my problem. Doesn't mean that you can't do it the other way. You absolutely can. But subtracting that 2x, you're going to end up with 2 negatives in your problem. You're going to have to make, it's just more places where we can go wrong, right? So I added that 4x. Now I've got a positive 8. I subtract it. I got 6x is equal to 6. I can go from there and get my answer. Okay. So you can absolutely get the right answer either way. I'm going to try to give you little hints along the way of how can we make it so that it's less likely we make a mistake. And that's going to be keeping things positive. Okay. Any questions about that problem? Okay. I want to put some steps down in your notes. Step 1. We haven't had to do yet. Well, I'm going to say simplify each side first. So if there's any combining like terms, if there's any distributive property, if there's anything that we can do to simplify first, let's do it. Before we start moving stuff side to side, simplify each side individually first. The next problem we look at is going to have that. Okay, we want to simplify first. Step 2, move all variables to one side. And that doesn't say move all variables to the left or all variables to the right. It says move them to one side. You get to choose which side that is. True?
Will there ever be 2 variables?
Not today.
No.
Eventually. 1.7, we get into 2 variables and more. We're going to simplify each side first. We're going to, step 2, move all variables to one side. After you move all variables to one side, and if you simplify correctly and all of that, then it's just a 2-step equation. It's just a 2-step problem like we were doing last week on the quiz. Okay, so step 3, I'm just going to put finish solving. Because at that point, you know what to do. Really, the only new parts here. First 2 steps, just simplify first, move all variables to one side, and then we're going to finish solving. so I told you this time we're gonna have to simplify a little bit. Okay, we're gonna have to get that first step. A little bit longer of a problem. Problems are getting longer, more difficult. Gotta do what we can, one step at a time. So to simplify each side first, use that distributive property. Then we can move the variables, then we can finish. Go ahead. Let's see what we can do. Do I talk to somebody? Say, "Yes, thank you." All right, walking around, I got a lot of the right answers wrong. Okay, first step, we gotta simplify. When we simplify, we are distributing. I saw some people on the quiz doing this incorrectly. Okay, and you got something wrong because you distributed to the first number, but the second number you just put -4. When you distribute, you gotta distribute to everything. So that's 9x minus 12. Here we distribute. Multiplying by 1/4, what is that the same as? Dividing by 4. Multiplying by 1/4 is the same as dividing by 4. So that's just 8x plus 6 if you're just dividing both of those numbers by 4. Okay, raise your hand and tell me which variable did you move here? Which one did you move, the 8x or the 9x? Cody, what'd you move? Why? There you go. So be specific about which one you're gonna move, right? Be intentional about it. So I'm gonna move that 8x over. That gives me 1x or just x minus 12 is equal to 6. I can add that 12 over. And as most of us got, we got 18.
Yeah.
There you go. Good deal. Any questions on that? Okay. Good. So big takeaways here. You gotta do the opposite of what you see. And be intentional. Be specific about which variable you're gonna move. Try to end up with that positive x value, or that positive y value, whatever it is. It makes one less mistake possible. All right, let's keep going. Now that we know what we're doing, let's see what we can do here. on your own, go ahead, solve this one out. This is one of my favorite examples to do all year. Because I like seeing your reactions when you realize something weird's happening. Right? Something weird happens here, right? What weird thing happens? Cody? It's a 0x. The x's cancel each other out, right? So let's take a look at what that means. I have 10x plus 8 equals 7 plus 10x. I go to get the variables together. I got a positive 10x. I'm going to subtract 10x. Well, if that cancels out here, it's going to cancel out here as well. It is not just an x left over, right? X is 1x. There is not 1x. There's 0 x's, which means nothing. There's no x's. So all I'm left with is 8 is equal to 7.
That's not right.
Is 8 equal to 7?
No.
Can 8 ever equal 7?
No. Yes.
No. 8 can never equal 7, right? So guys, what that means is there is no value of x that I can plug in to make these two things equal. There's nothing that I can plug in to make the two sides equal. Like that 18, that last problem, that 18 was the one number that I could plug into both x's and make the two sides equal. There is no such number here. In this situation, there is no solution. So we are going to start running into problems that don't have an answer. There is no solution. So on the paper, on the test paper, in a couple of weeks, you would write down no solution. Okay? No solution. So let's talk about when this occurs. This is going to happen, there's no solution, when your variables cancel each other out. If your variables cancel each other out and you are left with a false statement, 8 is not equal to 7. Okay, variables cancel each other out. I have a false statement. My answer is no solution. Okay, this is a false statement, right? So my variables canceled. I'm left with a false statement. My answer is no solution. Good.
So if you're left with like 7 equals 7, what would x be?
Yeah, so that's a great question. So let's say basic problem, I got 4x plus 7 is equal to 4x plus 7. First of all, aren't these two sides exactly the same? Right? Does it matter what value I plug in for x?
No.
It's always going to be equal, right? Because you're always just multiplying it by 4 and adding 7. If I can plug a 0 in, it'll work. I can plug a negative 20 in, it'll work. Okay? So in this situation, and we could continue to solve it out, get to 7 is equal to 7. If you're left with a true statement, what we say is all real numbers. All real numbers. And if you want to abbreviate that ARN, that's fine. All real numbers. That means it doesn't matter what number you plug in, you plug the number in, it's going to work. All real numbers are going to work. We say all real numbers because there are such, I don't want to confuse you, but there are such things as imaginary numbers. You're going to learn that in Algebra 2. Okay? So we're not going to talk about it now. We can talk about it later if you really want to. But the sentence is all real numbers. That's what we say. All real numbers. Okay? So again, these are special situations. These only happen if the variables cancel each other out. The variables cancel each other out, and you have a false statement, it's no solution. If you have a true statement, it's all real numbers. Doesn't matter if that false statement is 8 is equal to 7 or 100 is equal to 0, as long as it's not true, it's no solution. This is 7 is equal to 7, 0 is equal to 0, -2 is equal to -2. It's all real numbers. Okay. The other thing I want to point out here is from the very start, I pointed out that the two sides were the same, right? This is what we call an identity. Identity. Identity is when the two sides are exactly the same. It's like looking in a mirror, right? It's your identity. You're looking at the same thing on both sides. So an identity is when the two sides are exactly the same and we have all real numbers. So tonight in that homework, if you see that the two sides are exactly the same, right? Whether that's right away in the problem or as you're doing the work, you get to where the two sides are exactly the same, you can stop right there and say all real numbers. You don't even have to keep solving. If the two sides are exactly the same, all real numbers, be done. On the homework, I know it's a question. How are you going to put that in to big ideas? Big ideas tonight is going to look slightly different for you. They're going to give you the problem, and then instead of typing in an answer, they're going to have like 25 different possible answers for you to choose from. A bunch of answers at the bottom. And one's going to say all real numbers, and one's going to say no solution. Okay, so you're going to do the problem, you're still going to do the work, show it on the page, get your answer. If it happens to be no solution, then you're just going to click that button. Okay, if it happens to be x is equal to 3, then you'll click that button. Okay, if you get an answer that's not on that list, you're wrong. Okay, so go back and do it again. Okay. Any questions right now about variables on both sides? Yeah, sure. She's finishing the quiz. That's because she hadn't started. Okay.